Howdy and good day, fellers. Today in Algebra, we are going to be correcting CO16. Yesterday, we learned about and statements and or, but the homework was on the and statements, and then today we will work through the or statements. Or not. Get it? Okay. So this first one here, negative 14 is less than x minus 8 is less than negative 1. We know it's going to be an and statement because how it's set up. And what's what I'm looking for? Barring any special quirks, it's going to stay that way. Okay, that's some foreshadowing there for you. Anyway, so to get this graphable, we're going to get x by itself using opposite operations. And we talked about and statements having like three parts to them. You've got the limit on the left, the limit on the right, and then what's in the middle. Okay, so when you add 8, you're adding 8 to all three parts, and you get negative 6 is less than x, which is less than 7. Essentially meaning that on a number line, x is between negative 6 and 7. And the reason why this works out is because remember back in CO13, when we wrote inequality statements for various situations, we talked about there were two ways to write them. Negative 6 is less than x is the same thing as x is greater than negative 6, right? Which is what this graph shows. And then the other half of this, x is less than 7, is what the other half of that graph shows. So the reason why we can write it as one fluid inequality is because we can write inequalities two ways, and that's why we covered it in CO13. Kind of preface this. Okay. Any questions on that? Okay. Next one, we're going to start by subtracting 2 from both sides. Sorry, from all three parts. That gives us negative 3 is less than or equal to negative 5t, which is less than or equal to 2. In the middle, they just cancel out, and then our left and right limits are both affected. Now we're going to divide by 5, negative 5 rather, and when we do that, what happens? Our inequalities flip. So we get positive 3/5 is greater than t, which is greater than negative 2/5. And this is one of those quirks that you just have to be aware of. We didn't do anything wrong here, but notice that 3/5 is not on the left side of negative 2/5 on the number line, whereas here negative 14, negative 1, they're in the right spot, quote unquote. Negative 6, 7, they're in the right spots. But because we divided by that negative 5, now everything's flipped on us. So when you graph it, don't put your 3/5 on the left and your negative 2/5 on the right. That's not how number lines work. Okay, you just need to reverse it. Both get closed circles, and it is still an and statement. Yes, Webby? Decimals are fine too. You would get negative 0.4 and positive 0.6 if you went the decimal route. Either one's fine. Issues with that one? Yeah, Julia. Good question. How would you check your work here? Anyone have a thought? Gabby. Yeah, so if you pick a number that's within this number range here, what this solution means is that in order for the original inequality to be true, in order for negative 5 times t plus 2 to be between negative 1 and 4, t has got to be within that range, negative 2/5 to positive 3/5. So if you pick a number within that range, and Gabby said 0, okay, not only is it easy to check with, but it is actually inside the range, then you plug it back in. Negative 1 is less than or equal to negative 5 times 0 plus 2 is less than or equal to 4. Of course, multiplying by 0 just cancels this out. And so we get negative 1 is less than or equal to 2 is less than or equal to 4. Is 2 between negative 1 and a positive 4? Yes. So you know that you'd be right. Okay. If you picked a different number, if you plugged in 4, which is outside of the range, then your inequality would not be true. Okay, so you can check it either way. Anything else with that one? All right, the third one here. Negative 7 is greater than y minus 8 is greater than negative 12. Okay, so right off the bat here, did you notice anything peculiar about this third one?
Oh wait, no.
It's easy.
Well, let's work through it and see what we come up with. Okay? No? Gabby? Yeah, negative 12 and 7 are kind of on the wrong sides there. And instead of less than signs, which, we're kind of used to starting with those, we've got greater than symbols. Okay? So let's kind of work through this one and see what happens here. See how those quirks affect our final result. To get y by itself, we're going to add 8 to all three parts, those opposite operations. And we get 1 is greater than y, which is greater than negative 4. So if that's true, okay, let's kind of take a look at this here. 1 is greater than y. What's the other way to write that? What's the other way to write 1 is greater than y? Julia? Y is less than 1. And then the other half of this has y is greater than negative 4. Are we okay here? If we write this the correct way with negative 4 on the left and positive 1 on the right, do we still get an and statement out of that? Yes. Okay. Yes. So the only quirk here, the fact that we've got greater than signs, isn't a huge problem because those two numbers are kind of flipped, like we saw here. Okay. We just have to remember that when we go to the number line. So negative 4, positive 1, y is between there, and everything's fine. Okay. Questions on that one? The one word problem you needed to do with the debit card. The daily limit on your debit card is $150. Write and graph an inequality showing how much you can spend in a day. What are your two limits here, Lucas?
Less than or equal to 150.
Okay, t is less than or equal to 150.
And also t is greater than or equal to 0.
T is greater than or equal to 0. Okay, did anyone write that as a compound inequality? Right? How that would look, and you're not wrong, not wrong here, but we can write that as 0 is less than or equal to t, which is less than or equal to 150. On your test, you are going to have to write these as compound inequalities. I guess it didn't specifically say that here, okay? But t is between 0 and 150, right? And if you use a different variable, fine. But you can either spend $0 if you don't buy anything, or you can spend any amount up to 150. You can't go beyond 150 because that's your limit. You can't spend less than 0 because that doesn't make any sense, right? So
On your debit card?
yes, on a debit card. Different from a credit card. Debit card is tied directly to your bank account. Okay. Anyway, so between 0 and 150, that is the graph that you should have there. Okay? Good. Any questions on and statements? Okay, let's move to or. And I saw some of you kind of started experimenting a little bit as far as how or statements are going to look. We saw yesterday in our example with the water temperatures what an or statement's going to look like. You're still going to have two solution numbers on your number line, but instead of being connected, your graphs are going to be going away from each other. So the first one that we see back on the first page now is x is less than 5 or x is greater than 15. It's so nice of them to put the or in there so that you can clearly tell it's an or statement. And the thing about an or statement is whereas, in an and statement, when we got x by itself, we had to do things to all three parts. Here, you're getting x by itself separately. You're not solving the two inequalities together. You're solving them separately. In this first example, x is already by itself in both of them, so we can go straight to the graph. x is less than 5 is an open circle at 5 going left. X is greater than 15 is an open circle at 15 going right. And there we have it, right? It's an or statement because remember yesterday, x can't be both less than 5 and greater than 15. That's not possible. So x is less than 5 or greater than 15. How would you check this? If this were something that you had to solve through and everything, how would you check it? Yeah, Quinn.
For the first equation, you put in a number that's less or more.
Right. You could test each inequality separately, right? You could pick a number that is in this solution set, plug it into that inequality, see if it works. Is 3 less than 5? Yes. Okay, I'm good. Then pick a value in this solution set, plug it into that one. Is 17 greater than 15? Yep. So I'm good. What else could you do if you're looking for an alternate way? Yeah.
Take a number that's like out of 3 and like
Exactly. Pick something that is, not in either solution set. Maybe 10, right? Is 10 less than 5? No. Is 10 greater than 15? No. It's not going to work in either inequality. Okay? It's not often I get to use all 4 colors in one question. That's excellent. Okay? So one that we kind of have to do some prep work on. The first one in the second row. 2x minus 5 is less than negative 3, or 3x plus 1 is greater than 11. I'm going to draw this line down the center, just to remind myself to solve each one separately. You're not trying to solve them all at once. Focus first on just a 2x minus 5 is less than negative 3. Start by adding 5 to both sides, right? Relatively standard two-step inequality here. We get 2x is less than 2. Divide both sides by 2, and we get x is less than 1. Okay? Yeah?
How do you determine which number you're gonna use to add? How you took plus 5 and you added it to 3 and 5?
How you start to solve this here? You mean why I added 5?
Yeah.
So I added 5 because when you're solving an equation or an inequality or whatever, you want to start with any addition or subtraction, unless it's a fraction or there are parentheses, there's something else going on here. So what are we doing to x? We're multiplying it by 2 and then subtracting 5. So to undo that, we're going to do the opposite operations, add 5 to cancel this out, and then divide by 2 to get x by itself. But
Why can't you add 3?
Because our goal is to get x by itself. And so adding 3, it wouldn't be mathematically wrong to do. But if we add 3 to both sides, we end up canceling out what's on the right side. And we didn't really accomplish anything as far as getting x by itself. Right? There's still a constant over on the left side with x. And so instead of moving our solution to the side with x, we want to move everything to the other side, away from x. Yeah? All right, then we move to the one on the right. We got 3x plus 1 is greater than 11. We're going to start by subtracting 1 to move that constant over. And that gives us 3x is greater than 10. This one doesn't work out quite as cleanly as the first one, but that's okay. Dividing by 3. We're just going to leave 10 divided by 3 as 10 thirds, right? Because the decimal you have to round or it repeats, it's easier to leave that as 10 divided by 3 or 10 thirds. And our graph of this, x is less than 1, open circle going left. X is greater than 10 thirds, open circle going right. So the difference from an and an or statement, whereas an and statement, solving it all at once, all together, statement, you're working through each inequality separately. and then just graphing them on the same number line. Good? Follow me? Kinda? That's soybean? Okay. The last one here, 2 times x plus 7 is less than 8, or 10x plus 1 is greater than 1. We're looking for the value for x, or the range of values x can be, to make one or the other true. Remember, not both. X can't make both of them true. It's one or the other. So we're going to solve them separately to see what those ranges of x will be. On the left side, we start by distributing 2x plus 14 is less than 8. Subtract 14 from both sides. We get 2x is less than negative 6. Divide both sides by 2. And we get x is less than negative 3. Okay. This kind of goes back to CO15 a little bit in the multi-step, but still pretty standard. Then on the right side, 10x plus 1 is greater than 1. Start by subtracting 1 from both sides. And sometimes, folks get kind of freaked out by the 0 on the solution side and think maybe it means you can't solve it. It's not what it means, right? What it means is we're looking for a value for x that when you multiply it by 10 is going to be greater than 0. And so we're still going to divide by 10 to get rid of that coefficient to figure out what that's going to be. And what's 0 divided by 10? 0, right? So in order to make the original inequality true, for 2 times x plus 7 to be less than 8 or 10x plus 1 to be greater than 1, x has to be less than negative 3 or greater than 0. It can't be both. If x is less than negative 3, it's going to make our inequality on the left work, that 2 times x plus 7 is less than 8. If x is greater than 0, it's going to make the inequality on the right work. 10x plus 1 is greater than 1. Okay? But it's that one or the other. Can't be both. Yes, Brady.
Well, no matter what, will they go to
An or statement will. An or statement going, because the thing about an and statement is that 2 things must be true, right? With our water temperature, water has to be between 32 degrees and 212, whereas an or statement is one or the other, so they're going away from each other. Can't be both. Kylie.
Would you get it wrong if you put 0 first, then negative 3?
If you did put, are you talking about on your number line? So if you graph this and you put 0 on the left side, which is the incorrect order as far as how numbers go, watch what happens here. If I graph x is greater than 0 with 0 on the wrong side, and I graph x is less than negative 3 with negative 3 on the wrong side, it becomes an and statement, right? Which is a problem because it's very clearly an or. So yes, do not put your 0 and your negative 3 on the wrong sides. Your number line must be a true number line. Okay? Anything else? Good question. All right, soybean. Yes, or statements could be greater than or equal to or less than or equal to. The examples here all happen to be just less than or greater than. But on the second page, let's see what we have in store. Second page, the second one's got a greater than or less than or equal to. So that just means you have a closed circle, just like any other. Okay. So the 3 of them on the back side, the 3 or statements I'd like you to do for homework for tomorrow. Just remember to solve them separately. Okay. If you need to look back at how to solve an equation or an inequality such as this, 2-step inequalities, that was CO14. That's what you got there in both the first and the second one. The third one here, you've got multi-step. You can look back at CO15 for that. And then the 2 word problems down below. Yes, tapping into science here a little bit. There is a unique plant that only pollinates when it's less than 3 feet tall or greater than 5 feet tall. Write and graph an inequality showing the heights at which the plant pollinates. Okay? How do you know this is an or statement? Just by reading the question, Quinn.
Because it's
Right. It can't be both less than 3 feet and greater than 5 feet. That doesn't make any sense. Right? And it's got the word or in it, which is helpful. Okay? Then in the brain buster here, in a dance competition, routines must be 8 minutes, 30 seconds with a standard deviation of 10 seconds. Standard deviation, we first talked about that in CO11. Remember, that's the amount above or below something that's still acceptable. Okay? What's that? Absolute deviation and standard deviation are the same thing. Sorry, I should have made that clear. Yeah, absolute deviation and standard deviation are the same thing. So anyway, so 8 minutes and 30 seconds, that's kind of your target time. But then you have a deviation of 10 seconds above or below that that's still acceptable. Okay. However, routines that are 15 seconds longer or shorter than that range will result in a 2-point deduction. Create a graph showing the times for which you would receive a 2-point deduction. Okay. Very good. All right. You have like 15, 17 minutes to work. Any burning questions that you want addressed before we sign off today? Daniel? For the plant one? Hey, folks, I can't hear Daniel's question. What? So there is a bit of context here too. Daniel's saying that, well, technically, if we write the inequality, the height is less than 3 feet. There's a limit to that, right? It can't be below 0 feet. If you want to include that fact in there, great. That would be good. But I was going more for the application of an or statement. So I was actually pretty poor at science, so let's not get too sciencey on me here. Yeah. I don't even know if such a plant exists. I kind of made that up. So probably doesn't. All right. That is how you math.